The next session, we're going to get back on track. It's CCS Tech, Carbon Capture and Sequestration. We're going to be having an armchair conversation with Klaus Lackne from the Center for Negative Carbon Emission. We've spoken with him earlier, as well as Jens Nielsen, who's with a company called World Climate Limited. And you'll hear more about what they're doing with CCS Tech, economic, safe, and reliable. Well, take it away, guys.
Thank you. I'm Jens Nielsen, World Climate Limited, based in Copenhagen, Denmark. I'm stand-in today for Christoph Gebald from Climeworks, based in Zurich. Unfortunately, he couldn't come. The advantage, or maybe disadvantage for me, is that I know absolutely nothing about carbon capture and storage, so I'll be the one who asks all the stupid questions.
Go ahead.
First of all, Klaus, we've already heard a bit about the technology. You gave some very good outlines in one of the previous sessions. But someone told me once that if you want to predict the future, it will always be good to look back in history. And you've worked with this since 1995, correct?
This particular idea of air capture goes to 1999, but basically,
yeah.
Yes, I've been worried about climate change and carbon management since the early 90s.
Yeah. In that period, what do you think have been the main achievements? What has been developed?
Well, a number of things. When we started in 1999, I started with a simple observation. If you have windmills, they collect kinetic energy out of the air. If you build an artificial tree, you want to collect CO2. And what struck me is for the same CO2 reduction, the artificial tree is much smaller than the windmill. The windmill avoids CO2 by making electricity without using fossil fuels. So there's less CO2, and this takes CO2 out of the air. And there's more CO2 in the air, if you wish, than there's kinetic energy. And that got me going. And this was basically the idea in the first paper. We said back then it should be passive and it needs some sort of sorbent, but we didn't know yet what it will be. By now, we have a prototype running in the lab, and it's working. And that's quite a distance from where we were. Yeah. We also were involved at some point with a small company which wanted to sell it to enhanced oil recovery, and oil prices dropped to the point where that is not interesting.
Okay, so you would say we are at the venture stage, or what stage would you say?
I think from if you take the technical levels, we are right now probably at TRL2, okay. Which is saying it's working, it's in the laboratory, and it's ready to go out into a small prototype. I think the jump from here to 6 or 7 is actually quite small, because we sort of know what we need to do. It's now a matter of funding that and put together an effort which can actually build a prototype, ideally a 1 ton a day prototype, and then you can think going into mass manufacture.
Okay. One of the things that you've done many things in your career, and you've also looked at energy much more broadly than CCS technology, etc., right? If you look at the current challenge in the carbon budget, which I know is dear to you, how do you see the role of CCS technology, and how do you compare that role to for example, renewable energy?
I think first and foremost, we are very likely to go to renewable energy. If you had asked me 10 years ago, I would have said there are 3 big energy technologies which are big enough to provide the energy 5 to 10 billion people will need. When I started, it was 5.5 billion, now it's 7.5. I think we will probably reach 10 billion. And if you ask what's there, well, you could have solar energy, that's clearly big enough. You could have nuclear energy, that is clearly big enough, and for 100 to 200 years, you can do fossil fuels. And I would have then said, none of the 3 technologies are ready. And fossil fuels, because they create a disaster with climate change. Nuclear, because it's a proliferation issue, a security and safety issue, and it's expensive. And solar, I would have said, is expensive. I think the breakthrough you have seen now in the last few years is that solar has reached parity, and that is a revolution, and that's a first very enormous step. What makes me still hang on to the air capture discussion is the conviction that we have already overshot. In 1980, we could have had a good discussion of whether we should completely abandon fossil fuels and never get into a situation where we have to mop up after ourselves. But now it's too late. We will have to do carbon capture and storage in the generalized sense. I think coal plants will never do that because they were never designed to do it. It's awkward, it's costly. Honestly, those are stranded assets. So I'm not trying to revive them, but I do think we have 100 ppm in the atmosphere, which will have to come back out. And maybe that's from 450 back to 350, but it could also be from 500 to 400, because you saw earlier in the talk, we still have momentum going forward. It's not good enough to hold emissions constant. We have to get emissions to zero, and then we have to get negative to balance it out.
If you look at CCS technology, I believe somebody in the audience said earlier when the moderator prompted for reactions on CCS, what do you think in one word? Somebody said it's actually two words, science fiction. But is there any fiction, or is there still an element of fiction in CCS today?
By that you mean air capture, or you mean CCS in the sense Norwegians are doing and Statoil? That's existing technology. Air capture is on the verge of being new. I would argue it's like heavier than flight air, right? People told you it's impossible, and that's where the science fiction part comes from. And then somebody flew, and it worked. Right? The physics of heavier than air flight was clearly feasible, and all you needed to do is look out of the door and see a bird, right? And now all you need to do is look out and you see a tree. So we know it can be done. The question is, can you do it better and cheaper? And I don't think you will ever do it cheaper, but you can do it a lot faster.
Can you comment a bit about how you see the technology developing and scaling, and in terms of cost also decreasing?
I personally believe that in the short term, you will get idealists like you got on photovoltaics, like you got on recycling, who say, I want to take my carbon back. Then eventually communities will say, we need to get our carbon back. You hear it right now. Google and Apple are saying we want to be carbon neutral. Right? If you do this beyond just doing an accounting trickery, you actually have to pull CO2 back, because all of them drive vehicles, drive trucks, right? Even Google, right? And so if you have logistics networks, you somehow or another have to cancel out CO2 emissions. So you will have to get into this story somehow or another. And I don't think an offset which says somebody else didn't cut down a rainforest or did remove a little bit of CO2 from a power plant counts quite in that story. So you actually have to create true negative emissions. And that's how I see us starting. Possibly you say, well, it's too expensive still, I only pay for 10% of my emissions. But then gradually the price comes down. As we learn how to do that, then it becomes a regulatory issue. And if you look at an old example of that, it's sewage. People have argued in the 19th century, just like we do today, about CO2 emissions. And we dump garbage into the atmosphere. And you see how the discussion changes if you think about it as a waste management problem. If I were to tell you I leave my garbage in front of your house, you wouldn't take it for an answer that I reduced my garbage by 20% since last year. Nor would you accept it that I paid for somebody else's garbage removal. You want that pile gone, right? And so that is how we have to learn how to do this here too.
Okay. One of the key themes and one of the key conclusions until now at ARDE has been that we need much more collaboration. And I guess the carbon capture storage industry or the developing industry cannot do this alone. Who do you see are the ones that you need to collaborate with?
I think our biggest possible friends and supporters and collaborators could be the renewable energy industry. Because think of wind and solar as creating energy which comes out whenever the sun shines, whenever the wind blows. So you have no control over it. So you'd love to have a flexible consumer who can turn on and off. And that could be us. When there's too much sunshine or too much wind, we take it, we'll make hydrogen. That hydrogen can react with CO2 to make methanol or to make gasoline or diesel. And I would like to point out, we know how to do electrolysis for more than 100 years. We know since the 1920s how to take carbon monoxide and hydrogen to make fuel out of. So we can make plastics. All of this is known, right? So we are now at a point where we can start putting the pieces together and ask which pieces are still too expensive to make it put together. And you will actually find out that even at 1 cent a kilowatt hour, the electricity in a gallon of gas is a large fraction of the price. As a matter of fact, it costs more than air capture. So that's where we have to put teamwork together. The other partner is, of course, the oil companies, because sooner or later they have to figure out how to sell oil that's carbon neutral. And that could be the closed cycle we just talked about, or it could be sequestration. On the other hand, if we really put 100 ppm back underground, I don't think there's room for additional carbon dioxide from petroleum. So we would end up in a world which has liquid fuels because they are valuable, they're useful. Ships and airplanes and trucks can't do without it. And I think it would help cars because that Tesla with a little generator in the back could go 2,000 miles on a tank.
So back to the title of the session, economic, safe, and reliable. When is the technology economic?
After a few doubling in cumulative output. I think the APS, as I said earlier, said $600 for a really clunky technology. I think the people out there are really right now between $100 and $300 a ton. If you now, but nobody has built anything but a first prototype. If I build a car in a machine shop, it's several $100,000, right? If I get into mass production, those costs come down rapidly. Once it's below $100, it's interesting. And I think its potential is to get down to maybe $30 a ton.
Okay. And regarding safe and reliable, it is maybe already safe and reliable.
Since you're taking CO2, which has no business being in the air out, I think it's remarkably safe. I don't see that we use any complex, nasty chemicals, so I don't see us creating problems like that. So I think it's very safe. And compared to other geoengineering options, and I don't like this being viewed as geoengineering option, I think this is exceedingly safe because it basically removes the garbage we put out rather than saying, I compensate for this garbage to do something else to the planet and hope that that is all right. So from that perspective, I find it a very, very safe way of going about it. And I think because it's mass produced, it will be reliable.
Yeah. Do you think that CCS can solve all the problems we've had?
No, it's one of the players. It's just one of the players, but it's an important player in that it closes the gap where it currently exists. It doesn't displace others, but it does make it easier. And I think we're out of time.
We're out of time, so thank you very much, Klaus. Yeah.
Thank you.
Fantastic. Well done, and nice pinch hitting there.